Hello. In this video I will go through the procedures that you might take in filling out the Asteroidal Occultation Report Form for IOTA. The reason I made this video is because we've made a number of changes in this form, many to take into account integration corrections and VTI corrections, and these corrections are all done on the form, but you have to be aware of how that's done. When you open the form, it'll look something like this. Notice the version now is 559. Let me show you a couple of tabs that you might be interested in. There's an introduction tab, which just gives some real basic information as reminders. There's a tab for full directions, and that's if you need something to refer back to if something's not quite clear. But for the most part, you'll need the data tab. First thing to do is indicate whether the observation was a positive, a negative, or unsure. I would rather have you put down positive or negative at this point, and we can talk about unsure in your communications with me. You can tab through this form, which makes it a little bit easier instead of clicking on the cell. So I'm going to push the tab button right now, and it'll go down to the year, and so we can input the year, 2018. It'll go to the month, March. It'll go to the day. So let me put a day in here, and we'll pretend we have an observation to put in. And then it goes to the predicted time. This is for your location. The predicted time, probably from Occult Watcher or maybe from the prediction pages that Steve Preston has. This is a time for your location. Again, I'm going to tab through. All right, so that's the approximate time. Put in the asteroid number. Tab. Be sure that the asteroid number and the name match each other. That will cause problems later on. Under the star catalog format, you'll notice here that there are a lot of X's, and these X's are designed to show you where there needs to be a number when you put the number in the catalog. This particular star is a UCAC4 star, so I'm going to select that one. And notice, I know it might be hard to see, but there's 3 digits before the dash, so put those in, and then the dash, and then 6 digits afterwards. Well, the star catalog doesn't show that. It only shows 4 of them, so we have to put leading zeros in. I think the star catalog or the prediction shows 485-2811, but we need 6 digits. And you can see other formats have different numbers of digits that you should put in there. Like Tycho has 4, 6, and 1, and so on. So be sure you match the format of the catalog with the actual number. And don't repeat the catalog name over here, just the number is all you need. Right, tab, there's my number. Right, let's go down now and put a name in. I'm not going to fill an email in right now, but you should put your email in there. Yellow cells are not required. They're just useful information. Observing location. You don't need to put the USA in there. Just the location nearest to where you made the observations is a good thing. Under latitude and longitude, you can have a choice of how you want to input that. Just be sure that both of them agree with how you're going to put the numbers in. In this case, I'm going to put in a latitude number. Notice there's a space between the degrees and the minutes. Then we'll tab, make sure your north-south is right. We'll put a longitude in. Again, the space between the degrees and the minutes. West. Elevation in meters. Chances are you're using WGS84 as the datum, which is Google Maps and so on. Aperture of the telescope, make sure you remember this is in inches or centimeters. Some people have reported 100 centimeters when they meant 10 centimeters, so be sure you do that correctly. F ratio, if you're using a focal reducer, for example, on a Schmidt K-screen, you put in the focal reducer. Unless you're visually observing, there's no magnification to put in, and then you pick the telescope. Tab again. Now we need information about how you time the event. Most of us are now using GPS time inserted videos, so that's where you'd select that. If you're using a tape recorder with a time signal like WAWV, you might select that for a visual observation. But we'll put time inserted there. The method is how did you record the information? Right? Most of us are now using video as frame analysis. If you're using visual, make sure you put down whether or not you applied the PE. Some people use drift scan methods. That's perfectly all right, obviously. I'm going to leave it as video with frame analysis. Asteroid visible, just information that may or may not be useful. If you could see the asteroid before the event, put that in there. Now you have to indicate what the timing device was that you used. Most of us are now using the IOTA VTI. Some Kiwis are still out there. Make sure you indicate which one is which. If you have a different procedure being used, different timing device being used, be sure you indicate that. And finally, the method of analyzing the video. The occultation timing application, there's a number of choices here. Most of us are using now IOTA, IOTA, or IOTA. There's others, obviously. Ocular is an older version of a analysis program that is used by some, and manual is used in certain cases. For example, maybe drift scan. Let me put in IOTA for now, and we'll leave it like that. These all are very important things to include, along with the detector and the camera. Let's put the 120 in there. North America, most of us are NTSC. You may have a PAL system. When you go to exposure integration, there's some differences here. We're measuring in fields now, except for one thing. If you're using a non-integrating camera or an integrating camera with the integration turned off, you still have to put 1x in there. Kind of counterintuitive, but that's what you need to do. It's mainly for the corrections tables for their proper calculations. But in any event, the comment box does give you some information about how you can place the values in the exposure integration box as needed. So let me select one for the LawTech 120. If there's other information you need to tell us about with a detector, maybe filters and so on, you can let us know there. These two boxes show up as a tab for a different camera, and I'll show you that in just a minute. We'll put in the cloud information, so we'll assume it's clear, and we'll put steady there. Any other conditions, maybe it's windy or there's some fog moving in or intermittent cloudiness, you can put that in there. Now, where you enter times. Start observing and stop observing is important only if we're looking for satellites, not really important for other observations. And you are not to put anything in the green cells. Those are cells that will be corrected by the form when you put raw times in. So let's say, for example, you put an uncorrected time based on a IOTA analysis of 3 hours, 14 minutes, 58.045 seconds. The form now, based on all the information you supplied up here, has corrected that time to make it 3:14, 57.978. So if you change the integration value, for example, watch what happens. The corrected time changes because integration needs to be taken into account. If we change cameras, the value will change because cameras behave differently. If you change the timing device, sometimes, not always, but sometimes that will change. So you need to be careful about making sure all the settings that you have are correctly placed in the form. And then when you get done, these green times will be the correct times that will be reported. A lot of programs, IOTA and IOTA especially, provide you with 3 sets of information about accuracy. The 68%, the 95%, which is what IOTA is going to be using, and the 99.7%. PE is for visual observations. And the remarks over here, these yellow, are remarks about the times. If you have something special you need to write down referring to times, put that there. So let's put these in. And we'll not worry about that. And I'm going to leave those times the same. Obviously, you'd be putting in the times that you got. tab through the rest of these. Was this a miss? This is kind of a verification. If you answered positive up here, this will be no down here. If you answered negative at the top, it'll be yes here. Right? So we'll leave that like it is. If I tab one more time, second star lets us know that you observed 2 stars. One would be the primary, let's say, and the other would be the secondary of a possible double star. If that was the case, you'd be sending in 2 report forms. One with the answer no here for the primary, and one with the answer yes here if it was a secondary. We'll leave that as it is, as a no. Signal to noise, again, that's given by the analysis programs, and that's important information to place on the form as well. When you get done, if there's additional comments, whatever you think is important to know, you can place those down at the very bottom. All these corrections, by the way, are on the form. Down here you can see some other worksheets. I would advise not messing with those because I don't think you can mess anything up. I think we have it locked, but if you want to look at it, I guess it's okay. Have to acknowledge the work that Tony George did on creating all these correction tables and getting all these various parameters to work together to come up with these corrections. It makes your job and my job a lot easier because now we haven't got to be looking up corrections on tables and maybe getting the wrong information. But it's important that you input the correct information in these cells with the timing and the timing device and the camera and the integration and that type of thing. Now I mentioned a couple of other cells here that haven't shown up yet. Let me go down. The Run Cam Night Eagle Astro has a rolling shutter. And what you need to do from Live Movie is to place in the Y value. If you look at the output of Live Movie, there's an X and Y value for the star. You need to put the Y value when the D occurred. So let me put in a value here. The reason you have to do that is because the rolling shutter has to be taken into account. It doesn't see the frame all at the same time, like a normal astro camera might. So you need to put in the Y values there, and if you notice when I did make those changes, the value of the corrected time changed. So that's the only time these cells are used is for the Run Cam Night Eagle. Right. So there you have the new form. It's a little more complicated than it's been in the past, but I think in the long run it will save you time because all the corrections that you need to make will be applied correctly, and hopefully you'll have many observations to make, and this form will come in very handy. Thanks for watching, and good luck.